All right, so real quick, I will again put up what is supposed to be on your flashcard project. Okay, you can pause this, look at it later. All right, so here we go. I will be going through what I expect to see. The first one is a point. Okay, and hopefully you know that a point is a specific location. Okay, and then of course on the other flashcard you would have something like that. Now it's really important that you understand that this is always capital. There's a huge difference in geometry between lowercase and capital letters. Capital letters are always points. Lowercase letters can represent the name of a line. It's usually in cursive. But you need to make sure that you understand that this is important. It has to be a capital A, not a lowercase a. Okay? So as you label points and draw pictures, you need to make sure that you are using all capitals. If you use lowercase, you would be incorrect. Okay. Now the definition that's in the book is a little bit more, it's an exact location, but I would take this. And then of course you'd have another flashcard, it would say point, and then on the back it would have a picture. So I'm going to write down the word once, but I will give you what is supposed to be on the definition, and then I'll give you what the picture. Okay. All right, so for number 2, it is a line. Okay. Line is opposite rays. Okay. And it contains an infinite amount of points. Most of you already know you have to have how many points to make a line. Right, so it has at least 2. Can have more, can have an infinite amount, and they're opposite rays. So in other words, it looks like this. Okay, and you would name a line with any 2 points. So you could call this line BA. Okay. You could call it line AC. You could call it line CD. Doesn't matter what 2 points. These are all the same. As long as you use any 2 points. So understanding that what it is and then its notation is also important. Okay? That's how you write it. That's not how you read it. You read it as line BA. You don't read it as BA. Okay? So you have to understand the difference between this and what we move on. Okay? So again, the vocab word is line, this would be the picture, that's the definition. 3 is line segment. Now, this is the word that's not necessarily needed. This one is. Okay. Segment. A segment. Any 2 points create a line segment. Those 2 points would be endpoints. Okay. So any 2 points. So this is what a line segment looks like. Now, if you notice, line segments make up lines. So BA is a line segment, AC is a line segment, CA is a line segment. Going forwards and backwards on the same line segment doesn't change the line segment, but the different letters does. So you can call this one line segment AC or line segment CA. They are the same. Okay. But if I were to add another line segment, BA is completely different line segment than AC, but you can name them in different pieces. So you can look at this whole piece, you can look at this piece, you can look at this piece. It's like a first and last name. Okay? First and last name. If you say the last name first, the first name first, it's still the same person. Same thing here. You can call it AC or CA, it's still the same line segment. But it's important that you know that it's read line segment AC or line segment CA. Or you can read it segment, either one. But the key to this one is knowing, in some books it's called a segment, in some books it's called a line segment. 4. Midpoint. Okay, and this one was on the cover sheet. I'm not going to redo it. You should know what it was. It was on the original instructions. 5. A plane. This is not the thing that goes meh, 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 or a jet, okay? Different plane. Okay. A plane is a flat surface that extends in all directions. Forever. And they say infinitely. But now, on the planet Earth, do we actually have anything that is a plane? No. Okay, there's nothing that extends on forever. It resembles a plane. We use the example of a plane as a flat surface. Okay. This is theoretical. But it does go on forever. Okay, and what does a plane look like? Well, they usually draw an illustration that looks like this. Okay. They draw a flat surface and they put points. Now, the key to this is knowing that it's named with 3 non-collinear points. And we'll get to collinear in just a minute. This will be one of the new words that you're going to have that I didn't give you originally. It's named with 3 non-collinear points. Oh, no, it is up there. Good. We'll get to it. Okay, so here we go. A, B, C. Now, can you use more than 3? Of course you can. It's named with at least 3. Okay. This is the minimum number of points. You can call it A, B, C, D, E, F, G. As long as all those points are on the plane, you can use as many letters as that are there. But you have to use at least 3, and they can't be collinear. Like these 3 can't be collinear. That doesn't mean they all have to be non-collinear. It just means at least one of them can't be on the same line. And hopefully you know that when I draw this, A, B, and C are not on the same line. If I were to draw a line from A to B, C is not on it. If I draw a line from B to C, A is not on it. So this would be plane A, B, C. Notice there's not really a notation for it. Every once in a while you might see something that looks like this. But for the most part, they write plane. You can't write ABC because ABC could be a triangle. It could be an angle. A whole bunch of things have 3 letters in it. So you need to make sure that you call it a plane. This actually tells me the plane is the shape of a parallelogram, right? We don't use specifics anymore. So you have to know it's called a quadrilateral. It's got 4 sides. That's all you know. You can't say it's a rectangle. Can't say it's anything else. Okay, 6. 6 is an angle. Now, when you were little, angles are the same things as the corners. Yes. An angle is the corner. A corner is an angle. They are synonymous. Okay. An angle Okay, ray is a connection, or an angle is a connection of 2 rays meeting at the same point. She's going to the doctor today. They'll let us know more. Remember, this is your great-grandmother, not my mom. Right, and this, again, is named with 3 letters. The notation looks like this, and the important letter is the middle one. Okay, this is the letter that has to always be in the same place because it's the middle letter. A, B, C, or C, B, A. They are the same angle, but it's understanding that that middle letter is the most important. Okay. If you ever see this, it stands for the measure of angle CBA. Okay? So this stands for the measure of. This is a notation, the measure of. This is just angle CBA. This would be the measure of angle CBA. It's not read M angle. No, it's the measure of angle. You have to know what the M stands for. And again, you name an angle with any 3 letters, as long as the one in the middle is correct. All right, number 7. And we'll probably get through 10 today, and then I'll give you a list of other words that you're supposed to add to the list that you have. And we'll go through 10 today, 10 on Wednesday. Wednesday's video will be pre-recorded and posted online. Remember, I will not be here Friday. And you'll be working on the computers Tuesday, Thursday, and Friday. Okay, I just left off with angle. The next one is an arc. An arc is a part of a circle. Okay, it's part of a circle. It's measured in degrees. Okay, and you have 2 types of measurements. You have an arc measurement, which looks like this, arc measurement. And then you have the length of an arc. Okay, these are 2 different things. The length of an arc is a measurement, like inches, feet. Okay, so when you're dealing with this, the length of an arc has to revolve around a circle's circumference. So the length of an arc deals with circumference. The measure of an arc is strictly degrees. So how much does it curve is measured in degrees. How long is the curve is what the length is talking about. So you have to be careful because you'll see that they'll ask for the length of an arc or the measure of an arc. They're not the same. The measure of an arc is in degrees. The length of an arc is the actual length or piece of that circle. Okay? And an arc looks like this. That would be arc AB. That's how you would write arc AB. Hopefully you know that symbol above it stands for arc. Okay, arc AB. And you know arc AB is this arc is because anything less than 180 degrees has 2 letters. Anything greater than 180 degrees, anybody want to take a guess? Has 3. Right. So, some people go, why does it have 3, Mr. Fisher? Because it's telling me where I start, just like an angle. ACB, which means I'd go A, and the next letter I'd have to go to is C, and then B. Notice, that's greater than 180 degrees. AB is up here. It's less than that. So it tells you the direction in which you're going. These are the directions. Just like when you name an angle, they're the directions. When you have an arc, they're the directions. You don't always go in the same direction. One direction. Number 8 is a ray. A ray is not a drop of golden sun. Me a name I call myself. A ray has an endpoint and extends in one direction, infinitely. An array looks like this. the endpoint is always the first letter. Okay, so when you're naming it, it doesn't matter what the second letter is, it's that the endpoint is the first letter. So that means if I was going to name that ray, it would be named ray CA. And that is the symbol for ray CA. This in no means the ray has to go in that direction. This just stands for the word ray. That's all it does. It stands for ray. It doesn't tell me what direction the ray is going in. So if I would have written it like this, it still would be called ray CA, because the first letter is the endpoint. The second letter can be anything, but the first letter tells me where I start. The second letter tells me what direction I'm going. I'm going towards A. I'm going away from A. Okay. Hopefully you understand now why a line is opposite rays, because I have ray AC and ray AB. They go in opposite directions. They share the same endpoint in the middle. You're also going to learn that that's called a straight angle, but that's later on. The difference between a line and a straight angle is a straight angle must have 3 points, whereas a line does not always have to have 3 points. Bisect. Okay. To cut into 2 equal pieces. Please do not say to cut in half. If you start talking like that, you're going to have a hard time setting up the math problems that happens in geometry. This tells me that the 2 pieces are equal to each other, so you'd put the 2 equations or whatever they are equal to each other. This tells you how to do the math. A lot of kids think bisect means to cut in half. The problem is when you cut in half, that's not one of the problems we do. There is no cut in half problem. Okay, it's either 2 things are equal to each other or 2 things add up to a third. So you want to make sure that you understand that I'm putting 2 things equal to each other, or I'm adding 2 pieces together to get a third piece. Okay? Bisect, to cut into 2 equal pieces. And this is done with congruency marks. I'm going to give you a picture of both, of what it looks like, because it doesn't matter. Okay, we're going to get to cut into the congruency marks is the part we're talking about here. So if I do it with an angle, this congruency mark, that little curve, tells me that those 2 angles are equal to each other. That this angle here and this angle here are equal to each other. Just like if I were to do this, and this congruency mark is telling me the same thing. Now you'll notice that on line segments, the congruency mark is different than on angles. On angles, it's a curve. On line segments, it's a tick mark. Okay? This tells me that this piece and this piece are equal to each other. That's what those mean. These are big. This is the biggest piece of information in geometry. In other words, when you're looking for a picture, these are the things you're looking for. Congruency marks and right angle marks. And if they're not there, there's a reason why. Usually it's something you're supposed to know is happening. So most of the time you spend drawing pictures and adding those marks where they're supposed to go. Number 10 is a bisector. Bisector is the line or ray that does the cutting. It's the line or ray that does the cutting. Now, when I mean line or line segment. They're the same. Or not the same, but it's a line, ray, or line segment that does the cutting. So you have something that is bisected, and then you have something that is the bisector. The bisector is the thing that does it. I call this the knife. Right? You got a lot of things that bisect. What else cuts things into two equal pieces other than a knife? Scissors. What else? Sword, chainsaw. Okay? There's a ton of stuff that can do cutting into different pieces. Notice, not all of them are called the same thing. Well, that's exactly what happens in geometry. There's a bunch of things that cut, but they're not all called the same thing. Like a midpoint cuts a segment into two equal pieces. A line segment can cut another line segment into two equal pieces. A ray can cut an angle into two equal pieces. A line can cut a ray into two equal pieces. So you have to understand that there are different things that do the cutting. They're not all called the same. They don't all look the same. They all do the same thing. That's why I try to use the scissors and knife. Hopefully you know you would use them in different circumstances. Like you'd use a knife to cut a stick of butter. You would not use a chainsaw. Okay? That's a little overkill. Okay? Just like you wouldn't use a knife to cut down a tree. You would use an axe or a chainsaw. All right. And the bisector is the line segment. So if you want to draw that same picture from before, you would just draw an arrow to this. This is the bisector. In this case, this would be the bisector. Okay? So you can draw the same picture for bisector as you did for bisect. And the key is the line segment or ray. The one that's doing the cutting is called a bisector. Collinear. Collinear. That means points that are all on the same, and we want to take a guess? Line, right. These are points that are all on the same line. That's what collinear means. So when I give you a list of points and say, are they collinear, that means, are they all located on the same line? If one of them is not, then they're not all located on the same line. In other words, you can either be collinear or non-collinear. There is no third option. Like, well, yeah, maybe except for the one that's not there. That's not an answer. It's like, did you do your homework? I mean all of it. I don't mean, well, I did everything but one problem. Then that's not your homework. Okay? So you've got to understand that collinear looks like this. So if I did this, are A, B, and C collinear? No. Are A, B, C, and D collinear? No. Are A, C, and D collinear? Yes. So understanding what collinear looks like. So that's why I draw a picture that has one of them off, because B is non-collinear. Now, any 2 points are collinear. So if I just give you any 2 points, you're automatically collinear. Why? Because how many points do you need to draw a line? 2. So if they just give you 2 points and they don't draw a line, and they say, are these collinear? It's a trick question. Because you're supposed to know that any 2 points will always be collinear. move on. Number 12. I didn't think we'd get through all 15, but we will. Looks like. Yeah. Yeah. Supplementary. Two angles that add up to 180 degrees, okay? So supplementary angles, you're looking at the measurement. Okay. This is semantics. It's a play on words, okay? So if this is 45 degrees, this one has to be 135 degrees. Why? Because the two of them add up to 180. Supplementary angles are very close to another vocab word you're going to have, which is called a linear pair. The difference between supplementary angles and a linear pair is what it looks like. They both add up to equal 180 degrees. The difference is, the definition for a linear pair is two angles that add up to 180 degrees and share a side, a ray. They share a common ray. Okay? So in other words, it looks like this. Now notice the difference in the picture. A linear pair share a common ray. Both of these angles share this ray right here, AC. Okay? So AC is a common ray. So BAC and DAC are called a linear pair. They add up to 180. Are they supplementary? Yes. So you should see that all supplementary angles add up to 180 degrees, but not all angles that add up to 180 degrees are supplementary. This is a more specific name, a linear pair. A linear pair tells me they are connected. I'm hoping everybody, again, is writing all these down so that they have them for their project. Should make it relatively easy to get 100% A on this one. Okay, then we have complementary angles. And what are complementary angles? Hopefully you know it's not, oh, you look like a nice angle. It's not a compliment. I completely spelled that wrong, didn't I? Maybe not. Complementary angles are angles that add up to? No. Those are called supplementary. Complementary angles add up to 90. Now in geometry, there's three main numbers, 90, 180, and 360. Now I tell a lot of people, if you know your alphabet, you should be able to tell which one's which. Why? Because C comes before S. So that means C goes with 90, S goes with 180. C also comes before L. So, and you should know 360 is a what?
Spin.
In geometry, we would call it a circle. All right. We would call it a circle in geometry. It's not a spin. It's a circle. When you spin in a circle, right? We're talking about forms and shapes, so that's why these are big, okay? And you use these throughout the entire year, especially those numbers. So complementary angles are two angles in which they add up to equal 90 degrees. Do they have to be connected? Do complementary angles have to be connected? Sorry, I wasn't down there.
Oh, that's fine. It was actually a Pearson problem.
Oh, what?
We were having, yeah, it was just like, and like H3, only three of the kids could get on. That was it. And then in our G5, there was row or something, so it's crazy. So
Well, they'll have all day. Okay, so this would be complementary angles, right? 65 and 25. What do they add up to? 90, correct. All right, and last but not least, for today's number 15, which is perpendicular. That's two lines or segments that touch to form a right angle. Perpendicular looks like this. Now, I will tell you that this is what makes it perpendicular. So it's important. Sometimes they give you two line segments are perpendicular, and they have purposely not put the right angle mark. So like I said, geometry is all about redrawing the picture and putting in the marks that are supposed to be there because they don't always put them there. Okay, perpendicular. Two at line or segments that touch at a right angle. All right, so what I will do is I will have, or we can write down the other 15 words, or a couple of them. Should be able to get most of them in. So here we go. You're going to have a acute angle. An obtuse angle. And a straight angle. Now some of these you should already know. You should know what an incenter is. These are more difficult. You should know what an orthocenter is. Circumcenter. What a centroid is. You should know parallel. You should know perpendicular bisector. You should know what isometry is. You should know what a vertex is. Coplanar. Oh, I spelled that wrong. No, I didn't. Congruent. Similar. And transversal. All right, thank you very much.